So today's topic of discussion, we're going to do 3 problems. That's it, just 3. We're solving logarithmic equations. Okay. So here's the deal. Take a look at the question number 1, right? We learned about some properties. If there is addition between 2 logarithms, what kind of operation is taking place with the results? So, and don't mind me if I skip some steps, this is going to be the log of x squared minus 3x equals 1, because I multiplied those. Okay? What do we do from here? Well, I'm sorry. Okay. Well, logarithms are the language of exponents, and so if you reach a point in a particular problem when you can do nothing more and it's in log language, convert back to the exponential language. And that's probably where your answer lies. So, if you don't see a number down over here, what number is it? 10. Does that help at all? Of course it does, because when you convert back to the exponential language, right, this bottom number over here is the base. That's what it always stands for. This number over here is the exponent. And this one over here is the result. Look how neat my notes are now. I'm so proud of them. Okay. I know. So then this written in exponential form is 10 to the first equals x squared minus 3x. There we go. Come on. So what do you do from here? Don't mind. Tell me if you understand the step that I skipped. Go. You can, but before you start factoring, you got to set it all equal to 0. Yep. Yep, it's definitely on. Checked to make sure. Sorry about that before. And so from here, just got to factor, right? X minus 5 and x plus 2. We're trying to solve that out, so then you draw out your lines. That's x minus 5 equals 0. You know, we're going to add 5 to each side. Some people can already skip through this step. I'm just showing you out what all the work would look like. So that's one possible answer. And here's another one. And then I said that you have to check. And I'll tell you why you have to check. Yep, you're going to have to see which one of those numbers, if you plug them back in, you just have to make sure that both the numbers will work. And we talked about this a little bit before we started recording. You can never take the log of a negative number. So when you sub these back in, sometimes there's expressions. If after you get done simplifying the expression, you're still left with a negative number there, that answer doesn't work, cross it off. So please, 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 with that said, somebody's going to ask, don't necessarily just reject something because it's negative. Reject it because when you plug it back in, it doesn't work. So a great question was asked is that what do you sub back into? Whenever you're doing a check, let's do the first one. Right now, I'm just checking the fact that x is equal to 5. You sub it back into the original question that they asked. Can you do the log? Yep, and we're just going to sub in log 5 plus, what's 5 minus 3? Plus log 2 equals 1. And if you plug that into your calculator, that happens to be definitely true. Now let's try the other one. What happens when x is equal to negative 2? Well, you get the log of negative 2 plus the log of, what's negative 2 minus 3? Yep. You could try plugging it in, or you could say to yourself, well, this automatically can't occur, and this automatically can't occur, So you just, you know what you got to do. So 5 it is. You got to reject this. Yep. Yep. You got to write the word reject. Every day in high school. So let's have a go again. We're going to practice 2 more times, and then we're going to be done. I'm going to give you a minute or 2. Try and take that down. Did everybody get a chance to take down all the other notes yet, or no? Okay. All right, so there's lots of ways that you could attempt to do this problem, and all of them will ultimately get down to the same spot. Let me draw a line between 2 separate ways. The first thing that you have to do in both of them is that this 2 up over here has to pop back up on top. Is everybody okay with that? Whoops. I'm sorry. Hold on one second. Let me write it. It's not that that was wrong. It's just that let me write it out, because in both ways it's the same, and then I'll show you where the break occurs. Log 5x squared minus log 5 this equals log 5 125. All right. So now let's draw a line in the sand. 2 separate approaches. Method 1. Well, I'm OCD. Method 1 and method 2. Which one do you want to see first? Medium or easy? Easy? Let's go with method 1 then. This is the easy way. If you understand logarithms and how they're written, sometimes you can just see the answer. For example, what do I mean? Log 5x squared. Nothing we could do with that. But this next one over here, right? This bottom number, what is that? That's the base. This middle number over here, that's the result. 5 to what power is 5? 1. And if you didn't remember that, you could use your calculator, right? I taught you how to enter it in. So this is really log 5x squared minus 1 equals, what's this one down over here? 3. Right? And it just makes the problem simpler, easy to deal with. Okay, so that the next step now would be this. Log 5x squared equals 4, right? And from there, you can't solve it any further, so you'd have to convert it into exponential form, and you'd get 5 to the 4th equals x squared, and finally, that's 625 equals x squared. Okay, whoops, 625 equals x squared. And I'm just going to hold tight right here, and I'm not going to solve it because I want to go back to the other root. Okay, all right. So you want to see what it is? Yeah, if you took the square root of both sides, x is equal to positive and negative 25. Because 25 times 25 is 625, and negative 25 times negative 25 is 625. Okay. We're going to do the other way next. The other way you could have tackled the problem is you could have said, well, you know, I like, that's going to bother me, but whatever, the fact that it's a different color. The fact, you could say to yourself, I'm just going to use the laws of logarithms, and because these 2 logs are separated by subtraction, what do you do to their results? You divide them, so that's x to the, sorry, not x to the 5th. Yeah. X squared divided by 5 equals the log 5 of 125. Okay, now take a look. They both match almost perfectly. And so what you could do next is this. You could say, in order for them to be equal to each other, this stuff over here has to equal that stuff over there. So x squared divided by 5 has to equal 125. That's the same thing as 125 over 1. You'd cross multiply. Everybody loves to cross multiply, right? Oh my God, on the algebra regents, when somebody doesn't know what they're doing, you know what they do? Yeah, that is the funniest thing ever. You could always tell if somebody doesn't know what they're doing because that's what they do. And so you're getting the same answer. You're just getting it two different ways, and both of them are right. There's nothing wrong. There's nothing better about one way versus the other. But we got two answers, so you have to check them. So let's see. Let's check what happens when, whoops. What happens when x equals 25? Do you think it's going to work? Yes or no? Log 5, 125 minus log, hold on. This one, if you plugged into your calculator, that would work. So this one is not going to work because of this right here. So guess what your final answer is? There you go. And that's our answer. Right? Because logs cannot have negatives in the resultant spot. Okay. We got question number 3 to go through, and then we got that one homework problem. That's it. Let's get this party started. Whoops. The first thing that you do is, you take this number, you bring it back up top. Always, okay? So it becomes log, x squared minus log equals the log of 4. And now the next thing you do is use laws of logarithms. It's division. So I would say that the log of x squared over x minus 1 equals the log of 4. Mick. So here we go. Right? Check it out, Henry. Take a look. Everything else matches up except for that, right? So in order for those two quantities to be equal, guess what happens? That stuff has got to be equal. Equals 4. Equaling, what's up? Equaling 4 is the same thing as equaling 4 over 1. Then we do what everybody loves to do when they don't know what they're doing. Of course. Got to cross multiply. 4x minus 4. You set it all equal to 0. You factor and solve it. I apologize for going too fast for anybody. Turns out x is equal to 2. It's a perfect square. Whoops, my bad. Sorry about that. X equals 2. Now let's take a look at the original problem. If you tried to plug 2 in, would you get a negative in any of the resultant spots? No. So you're good to go. That's your final answer.